Here's the derivation of the equation we just had. We've got Vf equals V naught plus A delta T. This is one of our two most fundamental equations. We solve this for delta T, we get Vf minus V naught over A. We take the second of the most fundamental equations, displacement is average velocity multiplied by time interval, and we plug this expression for delta T in, and we get this. Then we simply do a little bit of algebra. When we multiply fractions, we're going to multiply the numerators and we're going to multiply the denominators. The numerator here can be simplified using the distributive law. Don't even mention FOIL to me because it doesn't apply to anything but binomials and I don't have much use for it. We're not trying to do algebra quickly, we're trying to understand what it is, and we're going to use the distributive law. Distributing over this plus sign, V naught plus Vf times this thing equals V naught times this thing, written right here, plus Vf times this thing, written right here. Now when we multiply this out, don't have much more room in the paper. I started to write it up here. You can see where I crossed some stuff out. But we multiply it out, what do we get? We get a V naught Vf here. We got a Vf times a negative V naught here, so we got a V naught Vf minus a Vf V naught. By the commutative law, Vf V naught is the same as V naught Vf, so we got V naught Vf minus itself. It goes away. We end up with the Vf squared that we get from this multiplication and the negative V naught squared that we get from this multiplication. So we're going to have Vf squared minus V naught squared over 2a, and that is simply the equation that we saw before as one of our four fundamental equations that we've now seen a derivation for. This is the form it comes out in, and then we simply solve for Vf squared. Multiply both sides by 2a to get the 2a delta s, and then add the V naught squared.